Writing exponential functions from tables and graphs. Okay, so now exponential functions is a whole separate thing. So exponential functions show a pattern of multiplication, okay, and or division as well. So multiplication or division. So when you see a table or a graph to where you can see that the pattern is that there's a multiplication each time, we define this as an exponential function. So it's written in this form of f of x equals a times b to the power of x, where a is that initial amount, our y-intercept when x equals 0, and b is that number that we're multiplying by, which is our growth or decay factor we talk about. Okay, our growth or decay factor. And if b is greater than 1, and this is a very important concept here, if b is greater than 1, you know, this number in here, if this is greater than 1, then that means that there's growth. And that makes sense, right? Because if you continue by a multiplication pattern of, say, 2, then it's going to keep on multiplying by 2. It's going to grow and grow and grow and grow and grow. So if b is greater than 1, it shows growth. But if b is less than 1 and greater than 0, we're going to stick to the positive values for b. If b is less than 1, between 0 and 1, less than 1, it's going to show decay. And that makes sense as well, right? Because if you're less than 1, let's say like a half, if you keep multiplying by a half, it's going to get smaller. Like 100 times a half is 50, and 50 times a half is 25. And 25 times a half is 12.5. Like it just gets smaller and smaller and smaller. So if you have a number greater than 1, that's going to represent growth. And we're talking about the b value in here. We're talking about this b value in here. If it's greater than 1, it's going to be showing growth. And if it's less than 1, and more specifically between 0 and 1, it's going to be decay. So just keep that in mind when we start to look at these equations. Okay. So number 1 says determine whether the following exponential functions represent growth or decay, then write their equation. Okay. So A, if we look at this, you know, it looks like the pattern here, and these are going by increments of 1, so we don't have to worry about that too much. If we look at the pattern here, it's multiplying by 4. So it's exponential. It's multiplying by 4. And obviously it's growing. It goes 5, 20, 80, 320. This is growth. So I'm going to circle growth. Now let's write the equation. So I'm going to write the equation with f of x. This is the f of x table. And remember, the formula is a times b to the power of x. Well, a, as it says up here, is our initial amount. It's our initial amount. It's our y-intercept when x equals 0. Let me erase some of this pen work. It's getting a little overwhelming to look at. Okay. So if we look at our table, the y-intercept is 5. It's when x equals 0. So it's going to be 5 times b to the power of x. Now, b is what we're multiplying by each time. And that, in this case, is 4. So 4 to the power of x. That would be the function rule. Let me show you b. This, if we look at the values, it's going from 243 to 81 to 27 to 9. This is definitely decay. It's decreasing. Now let's write the function. The y-intercept, where it's at 0, is 243. So I'm going to write g of x equals 243. Now I need to figure out this growth factor. What is the pattern? The pattern here looks like it's dividing by 3. It's dividing by 3. But we write this in terms of multiplication. So if you're dividing by 3, you're really multiplying by 1/3. So the growth factor, or I guess it's actually a decay factor because this is a decay, is 1/3. So notice on letter A, it was growth, right? We saw it increasing. And notice that growth factor was 4, which is greater than 1. So I'm referring back to these statements right now up here at the top of the screen. It's growth. And on B, that growth factor, or decay factor, I should say, was 1/3. And it's decaying, and 1/3 is less than 1. So it all checks out. Okay. C. This looks like it's growth. It's going from 30 to 60 to 120 to 240. And more specifically, it looks like it's multiplying by 2. So that's going to be our B value. Our A value is the y-intercept, which would be at 60. So I'm going to say h of x equals 60 times 2 to the power of x. Let me do D. This looks like a decay. It's going down. More specifically, it looks like it's dividing by 2. Or in other words, multiplying by 1/2. So our equation, I'm going to say k of x equals. Now here's the thing, I need the y-intercept. So I got to look when x is 0. Unfortunately, this table doesn't have a spot where x is 0. So I'm going to have to backtrack. So if I backtracked and kind of created a spot for 1 and then a spot for 0, what would go in those spots? Well, it's dividing by 2, right? It's going the pattern, it's multiplying by 1/2. So if this is 25, I know this must have been 50. So I'm kind of multiplying by 2 to go up. And at 0, it would have been at 100. So I just kind of use the pattern to get back up to when x is 0. So I know the y-intercept is 100. The growth factor is 1/2. And then so power to the x. Yeah. Okay. Hopefully those 4 examples are a decent amount for you. Let's get on to the graphs now, okay? Because the graphs are just like this, but I'm gonna let you do the other tables, do your best with it, and then I'm gonna jump on to the graphs. Okay. So same thing. Determine whether the following graph exponential functions represent growth or decay, then write their equation. All right. So A, I'm looking at this graph. When you read it left to right, it's definitely growth. It's going up, isn't it? It's going up. This is increasing, right? That's an increase. That is growth for sure. So I'm going to pick growth. And you can tell by some of the points anyways, right? Like at 0, it's at 20. At 1, it's at 60. At 2, it's at 180. So this to me clearly shows growth. Now let's write the equation. And remember the equation, we just need the pattern. What is it multiplying by each time? And the y-intercept. Well, the y-intercept's at 20, right? So I'm going to write my equation. I'm going to use y for this because it doesn't give me a name for this function. I'm just going to say y equals 20. And the growth factor from 20 to 60 to 180, it's multiplying by 3. So 20 times 3 to the power of x could be the equation. Let me show you B. This one looks like decay. It's sloping down as you read it left to right. Now the y-intercept is 80, so that's good to know. And then at 1, it's at 20. At 2, it's hard to tell, but I'm going to assume that's 5. So the y-intercept is 80. And it goes from 80 to 20 to 5. It looks like it's dividing by 4. So we need to write it as a product, an expression with a multiplication. So if we're dividing by 4, that's the same thing as multiplying by 1/4. Now, let's just say you're really bad at your division and you don't understand that 80 to 20 to 5 is dividing by 4, and you can't really compute that to a 1/4. If you need to, you can just take your calculator, and do 5 divided by 20, which is 0.25, and then convert it to a fraction, which gives you 1/4. So that's one way to do it. And I'll repeat that maybe on a couple more examples. So I'm going to let you do C and D. Let me do E and F. So this looks like a growth. I have a y-intercept at 13, and because this one's actually giving us points, which is helpful. And then it goes from 13 to 52 to 208. So let's say you can't figure out what that factor. You're like, 13 times what is 52? You don't know? Like, you can't figure it out? Just use division. Use division. So if you can't figure out what it's multiplying by, use division. Do 52 divided by 13. 4. It's multiplying by 4. 13 times 4 is 52. Or you could do 208 divided by 52, and it gives you 4. 52 times 4 is 208. So that's how you can figure this out. So the equation would be y equals 13 times 4 to the power of x. Next one, this looks like a decay. So it goes from 600 down to 120 down to 24. So we have the y-intercept to 600, but you may be stumped again about, okay, what's the growth factor? What's it dividing by? How am I supposed to figure this out? 600 to 120. I'll tell you right now, it's dividing by 5, or in other words, multiplying by 1/5. So if you can't come up with that 1/5 on your own, just use division. Do 120 divided by 600. I got 0.2, and then hit second, and then second the back arrow will change it to a fraction. It's 1/5. So this function, this equation, would be y equals 600 1/5 to the power of x. So I'll let you do the rest. Now, with this down here, be very careful, because here it doesn't tell you the y-intercept. So you're going to have to get that. Okay. You're going to have to get the y-intercept. And then and you don't just eyeball it, even though you could probably just eyeball a guess, but look at the pattern. Right? So try to figure out what goes there. And then on this one, it's not going 140 to 35. It skipped one. So you got to figure out what the heck is that. And again, you can probably eyeball that as well, but you got to figure out what that is to write those equations. So those are a little bit more challenging because they're a little puzzly. Okay. But you do the rest.